Hello students, welcome back. In the previous video, I showed you how the parametric curves arise. Kind of like this. X is the horizontal position, Y is the vertical position. Put together, then we have the position of a certain particle at given time, and as time changes, the position of this particle changes. It moves around and the trace becomes a curve, kind of like this. Okay, in this video let's talk about the calculus of it, that is, the tangency problem. In short, you have to remember this formula. The derivative of y over derivative of x is the slope, y prime over x prime, evaluated at time t0. Let's postpone the theory a little bit and let's do at least one problem, maybe two, before coming back and talk about the theory. Well, here's an example. X is 3 cosine of t, y is 2 sine of t. Why do we have this extra space here? Okay, x is 3 cosine of t, y is 2 sine of t, evaluated at t equals pi over 3. Alright, what is x0? It is 3 cosine of pi over 3, isn't it? And you can calculate it. It's 3 times what is cosine of pi over 3? That's 1/2. So it's 3/2. What is y0? It's 2 sine of pi over 3, isn't it? 2 sine of pi over 3 is square root of 3 over 2. So this whole thing is square root of 3. So what do we have? x0 is 3/2. y0 is square root of 3. In short, we'll anticipate this as the final answer. X minus x0 plus y0, the slope point equation of the line, and this will be 3/2 and that will be square root of 3. Or if it fails, we may have a vertical line. Most of the time you're going to get something like this. Now this slope, oops, I'm clicking in the wrong place. Okay, this slope follows the slope formula. M equals to y prime of t0, t0, over x prime of t0. So if you find out two derivatives, y prime and x prime, and get the fraction and then plug in the numbers, you're going to get what you want. Shall we find out? Okay, let's go ahead and find out. What is y prime of t? Derivative of this one. So this is 2 cosine of t, isn't it? Derivative of sine is cosine. Now what is x prime of t? 3 cosine of t, you have to take the derivative of this. 3, and then what is derivative of cosine? Is negative sine. So that's the fraction that we are looking for. So my slope is this quantity evaluated at t0, and t0 in this case is pi over 3. So we have to put in pi over 3 here and pi over 3 there. Oops, mistyped. Oh, by the way, let me increase the font a little bit. Okay, let's complete this computation. What is cosine of pi over 3? It's 1/2. What is sine of pi over 3? It's square root of 3 over 2. So this whole thing becomes negative 1 over 3 square root of 3 and over 2. So that goes to the numerator. And looks like this is what we have. Let's see. Shall we simplify this thing just a little bit? Multiplying 3 to both numerator and denominator, multiplying square root of 3 to both numerator and denominator, we get 2 square root of 3 over 3 times another 3, so we get 9. So that is my slope. And that's going to go over here. So what do we have as the final answer? Y equals to this quantity we just calculated, x minus 3/2 plus square root of 3. And there goes the tangent line. Well, here is the verification. Well, Mathematica did not rationalize the denominator. It simply used 2 over 3 square root of 3. That's okay. It's the same quantity anyway. And we have this kind of curve and this kind of tangent line. Open up the solution, we have something, well, pretty much the same thing as I just did. Here I broke up this parenthesis and got slope-intercept equation, but as a matter of fact, I don't like these. I would much rather stop here at slope point equation. Let me see, I think I have sufficient time, so let's do just once more before coming back and talking about the justification. Basically the justification of the slope formula. Let's see, let's do this. And we have this kind of interesting curve, beautiful looking curve aesthetically, and x is here and y is there, so let's find out the tangent line. Okay, how about x naught? All you have to do is plug in t equals to pi over 6 from here, and then plug in pi over 6 here. And what do you get? Pi over 6 times 2, so it looks like this can be simplified into pi over 3, pi over 3, and then this is again pi over 3. Alright, what is sine of pi over 3? It is square root of 3 over 2. So if I simplify this thing further, 4 divided by 2, so this is 2 square root of 3, and cancelling out with this 2 square root of 3, we just get pi over 3. Or you can just run it with calculator and then you're gonna get pi over 3. How about y0? Well, here is the expression, and I have to plug in t equals to pi over 6 as before. Now what is this quantity? This is cosine of 5 pi over 6. Oops. And what is cosine of 5 pi over 6? 5 pi over 6 is in second quadrant, so this expression has to be negative. And this is negative square root of 3 over 2. So what do we have in the end? 2 times negative square root of 3 over 2. The denominator cancel out. And then negative square root of 3 plus square root of 3, oh, they all cancel out, and all I have is just pi over 6. Conclusion, we're expecting this kind of line, m x minus x naught plus y naught, where y naught is pi over 6 and x naught is pi over 3. And of course, what is my slope? We have to work it out through the derivatives. Or it could be a vertical line, but look at the picture. It doesn't look like a vertical line, so let's just work with this. Now, what is a slope formula? M is equal to y prime of x naught over x prime of t naught. As a matter of fact, this should be t naught, excuse me. This is a slope formula. So let's find out the derivative of y and derivative of y, and let's get it done. Derivative of y for derivative of t is 1. Oops. Okay, sorry. Derivative of 2 cosine of 5t, what is this? Minus 10 sine of 5t. The derivative of cosine is negative sine, and by chain rule we have to multiply by 5, so that's what we get. Derivative of square root of 3, that's plus 0, so that goes out. All divided by the derivative of x here. Derivative of 2t is 2. Derivative of sine is cosine, so we have 8 cosine of 2t. Additional 2 comes out because of the chain rule, and the derivative of this is 0. Oh, by the way, this is the derivative computation. After plugging in t naught, we should have t zeros. What is t naught, by the way, in this particular case? It's pi over 6, isn't it? So pi over 6 goes here. Pi over 6 goes here. And this turns out to be 5 pi over 6 after that. And then this is 2 pi over 6, equivalently speaking, pi over 3. So what do you get? 1 minus 10. And what is sine of pi over 6? What is sine of 5 pi over 6? Excuse me. It's 1/2. Second quadrant, sine is positive, so no sign changed. And what is cosine of 2 pi over 6 or pi over 3? That's 1/2. So we have this quantity here, 1 minus 5 over 1 plus 4. That's negative 4 over 5, isn't it? Did I do this right? And that's my slope. So the final answer here is negative 4 over 5. That's my slope. And oh, I just made a mistake. It's supposed to be negative 2/3. Oh, okay. Let's try to find out an error very quickly. I can't find any mistake in my computation. I have a feeling this computation, this coding is wrong. Let's see what we have. And this is right. Yes, so there must be some mistake in my part. Oh, alright. The derivative computation here. Derivative of this. Cosine becomes negative sine. Nothing wrong here. Oh, I found it. I missed this 2. This should be 2 plus 4 and negative 4/6. And consequently, this should be negative 2/3, as we have over here in Mathematicas computation. Okay, here's the solution. By the way, if you open up this cell, you can see the whole solution there. Yes, this is 2, and then you have negative 4/6.